Hey everybody! Today's video is going to be a little bit of a introduction into loops. Now, I've got my project ready to go here. I named it, and it's just a console app, so I'm going to hit create and save my other project that was open. Here we go. So, what a loop is. Effectively, it's just a single line or two of code, but it allows you to do a whole lot of different things that you can't do prior. What I mean by this is it allows you to run code multiple times. So in all of our previous code that we've written, the program will run, and no matter what we put in, what we click on, what we do, that code is only going to run once. Now we can have a whole bunch of nested ifs and things like that, but the code itself only runs the one time. Now there are times where you want something to run maybe several times, maybe until a certain something happens. Maybe I want to display something on the screen 10 times, 100 times, a million times even. The code to write that is exactly the same. You only change like one little thing in the code and it can change the number of times it goes. Now maybe I don't know how many times I want to run something. Maybe I just know that I want to go until a certain thing is true. A good example of this would be any program, any video game. A video game has what's called a game loop, or your main loop. It's essentially the loop that runs the whole thing, and it goes until you decide to exit out of the game. It goes until you decide to quit, basically. That's the main game loop. It runs all the code that keeps the game running. Even when you back up into, let's say, the main menu or something, that loop is running, waiting for you to click a new game or continue or load or whatever it happens to be. There's a loop going. So let's talk about the different ways we can make loops in C++. Now, I mentioned before that we can go a certain number of times and all that, and that is effectively just a very simple for loop. It has a very simple structure. It's kind of hard to mess up once you've written it out, but I mean, it can be done. But let me go ahead and write it out, and I'll explain what each little part is. So it starts with the keyword for. And I will, of course, write out the rest of this, and then I'll explain what's going on here after I get it all written out. There we go. And of course, we have more braces because. So we'll print, say I is now I, and of course, we'll just say inline. There. Okay. Now, this is your basic for loop. Now, for this, we start with the keyword for. We have what's called a start variable. We have an end condition, in this case. I'll just try to do it this way. Semicolon, semicolon. And then we have some sort of counter or incrementer. In this case, it's going to increment it. Now, in this case, we have int I equals 0. Now, that I doesn't have to be I. It could just be simply count if I wanted it to be or something. Well, if I can spell count correctly. It's just that historically, when you make a for loop, it's I. If I make another for loop inside of this, it's J and K. And historically, probably goes back to, you know, ancient times, I guess you could say, by most people who's probably watching this recollection. But early days in programming, certain letters were reserved and used for other things. I was one of those first letters that wasn't. So they decided to use that whenever they made for loops. And if you look at any code for any language, if there's a loop in there or something, they usually start off with like the I variable for it. Uh, so just so you know a little bit of the history behind that. Now this is where we start. I is going to be 0, right? And to end, I has to be 5 or greater in this case. Now, if I said less than or equal to 5, then it would have to be 6 or greater. But this, as long as it hits 5, 5 is not less than 5. This is our basically our go condition. In this case, while I is less than 5, this thing will keep going. And every time it goes, it adds 1 to this. This I++ that you see here is the same as I equals I plus 1, right? That. Now, I could alternatively also do, I minus minus to subtract 1. We could say I plus equals 2, and that would just add 2 to it, or 10, or whatever other number I want. So you kind of see how that runs. Now, each time this runs, I'm going to print out I is now, and then whatever I happens to be. So I'm going to zoom out so we can run this. Here we go. I is now 0, 1, 2, 3, 4. And notice 5 doesn't display. And the reason for that, again, is as soon as this hits 5, it stops. So here's what happens. And this is why loops tend to be the hardest topic in intro programming for people. But it's used in literally every program. And it can actually make your programming significantly smaller. If you know how to properly use loops and arrays or lists or other things, you can turn a 1,000-line coding project into a 200-line coding project, and it would still do the same thing. In this case, I is 0. We come down here and we print out I is 0, which it does. And then once we get here, it's going to come back here and check that condition. Once we get to this end 4, the I++ happens, and I is now 1. So is 1 less than 5? It is. So we're going to print I is now 1, which you get over here. And then it's going to go down here, and it's going to increase I by 1 again, and it's going to be 2. Well, 2 is less than 5, so it does 2, and 3, and 4. And once we hit 4, it goes down here, does this whole thing. We come back up here. 5. Well, 5 is not less than 5, so it breaks. Now, if I said less than or equal to 5, then it would go one more time. It would go, 0 to 5. But since I did this, it's going to stop right at 5 and not print that. Now, I can change the start position by going here and saying 2, for example. Then it would print 2, 3, 4. So that's the start, that's the end. That's how you know how this goes. Now, this for loop has a very strict structure. Those are the 3 parts of it. Your start, your end, and all that, as you can see. And it always has to be built this way. So it's pretty hard to mess up once you get it working. Now, what if I did this, though? If I took that out, then I would never went up. Or if I made that a minus minus, well, I is going in the opposite direction. Then I could mess up this loop. You could have what's called an infinite loop, which would be a loop that doesn't end. To end, the loop has to meet the ending condition, and if it doesn't, then it goes on forever. Now, the other type of loop we talked about was the while loop. And I would say a for loop is specific in that it goes a certain number of times. Now, I don't necessarily have to say that number. Maybe in the program, I ask what that number is up here, and then I can just plug that variable into this. So in this case, that's still going to run 5 times because number is 5. If this was something I use cn for to type a number, then this could be 5, 10, 100, 1,000. And the nice thing about this is I don't have to change anything here to make this go, like 5 million times or whatever. I just change a number, and it will go 5 million times without having to do anything else. So let's look at the other type of loop. Now, this one's going to be my while loop. And I'm going to make it exactly the same as this for loop. But there's a few other things to point out here. Uh, we need all the same parts for the most part. Int I equals 0. And I will say while I is less than 5. Now, I'll see out. And we'll just copy the same thing here. Copy and paste. There we go. Now, I have my start condition. I have my end condition. I'm missing one thing, and that is the counter. If I run this right now, I will have what's called an infinite loop. And this loop will go on and forever. And I'll have to force close this window, essentially. Usually Control C does that. Sometimes there's a little stop button down here to stop it when it's doing that type of thing. But I want I++, so a counter. Or again, I could say, plus equals 1, and it would be the same thing. Or I equals I plus 1, any of those options would work. Now this is the exact same as this. And if I run them, okay, well, hang on a second there. I don't know what that was about. Oh, apparently I have a play pause here on my magnifier. I did not know that was there. Well, anyway, I learned something new apparently. Okay, well, that doesn't help us, but I'm going to run the program this time. And we'll see I is 0, 1, 2, 3, 4. I is 0, 1, 2, 3, 4. You see, they do the exact same thing. There's no change. I have the exact same parts of this. Now, the difference between these two things, the while loop can do the exact same thing as the for loop, but it can also do more. I can do the while loop until a certain condition is true. For example, if I was playing a game, I can say, do this while I haven't hit escape. Do this while they haven't, hit the box or something. While the player isn't dead, keep running the game or whatever. So while they haven't chosen to, click on this particular part of the menu or something, do this. So you can do an endless condition, kind of, or a specific condition. It doesn't necessarily have to be a count in a while loop. A for loop, however, it has to be a count. You have to know how many times this is going to run. And a lot of people get confused with these two things because they'll try to use a for loop because, we've done it a couple of times. It seems easier. But what if I'm doing a program where I don't know how many times I need to do something? Let's say I have to guess something. And I get as many guesses as I want. And once I get it right, the program ends. Well, this loop will go X number of times. Maybe it takes me 1,000,000 guesses. Maybe it takes me 1. So I can force close this if I want to, like just force exit out of the loop. That's not the best way to code things, though. But I can make a while loop until they get it right. And then if they get it right, the loop will just naturally end. That's one of the benefits to a while loop. It can do the same thing a for loop can, but it can do more, essentially. But a for loop is still particularly useful. That doesn't mean I'm only going to use a while loop for all these. If I know I'm going X number of times, a for loop is very simple and efficient. I can just, boop, there's the structure, don't have to do anything else. Don't have to worry about putting these in the right place. That's the line. Copy and paste, change some numbers, that's it. Depending on the program, I may change a couple other things. But I need to go 20 times. Well, there you go. 1,000,000 times. There you go. An unknown number of times, then I would probably need to use a while loop. It just depends on the program. Now, there is one other thing I want to point out, and that is this. If you notice, I have int I equals 0 here. Now, if I come up here and say int I equals 0 up here, and let's see if I run this, if it has any complaints. Oh, there were build errors. Were there? It's not highlighting my build errors, but I'll run it anyway just so we can kind of see it. Let's see, did we run? Yeah, we actually ran a little bit. But there's a slight issue here. My int I is here. Let me see, does it still say there are build errors? Yeah, it says there's build errors. I'm not sure why it's not showing, but the error is I've already defined I can't define it again in these other two places. So if I take this out and I run this, there shouldn't be any build errors anymore. You'll see there it is. Okay. Not sure why that's not highlighting like it should. Maybe my thing's a little wonky. But no. But then you may ask, well, I named it here. Why is it not complaining when I do it here? This right here, the I, only exists until we get to this brace. It's inside this loop. There's a very important word you'll learn called scope, not to be confused with the mouthwash. What scope means is essentially where you define something is kind of where it lives. If I define something inside of a brace, it only exists inside that brace. So if I were to come down here and say int Bob or something equals 9, and then at the end of that loop, I were to try to print out, Bob, I can't. In fact, it's going to tell me it doesn't know what Bob is, essentially. Identifier Bob is undefined. Bob only exists in these braces, between these braces here. That's what scope means. Now, if I were to define Bob all the way up here, or even more so up above everything else, then everything will be able to know what it is. I don't need to define it a second time. If I define it all the way up here, you have what's called a global variable. Everything in the program knows what it is. And that can be great. You don't have to do what's called passing a variable back and forth between other little places because everyone can see it. Now, the downside is everything can see it. Sometimes you don't want other parts of the program that maybe other people are working on to be able to see your variables and change them however they want. You want them to be a little more compartmentalized. That's something for another day. But just to give you kind of a analogy of what scope is. Let's say the mayor of your hometown. Maybe you know who they are, maybe you don't. But let's just assume that most people in your hometown know their mayor, know the name. They've maybe seen him in the paper, maybe they voted for them, that sort of thing. That person is a local variable, which is what this is. This is a local variable because it's local to this little area. Now you may think, well, the mayors should be pretty famous, right? Well, what if the mayor goes to another state? Is anyone going to know who that person is? You think they're going to walk in there, don't you know who I am? The mayor of blah, blah, blah. Yeah, good for you. That's not even the same state. So it really doesn't matter. They are a local variable. They're famous locally, but not anywhere else. Now, if we were talking about a movie star, for example, someone in a big blockbuster movie, a lot of people saw it, then they would be famous globally. They would be what's called a global variable. Every little thing here would be able to look up and see what they are. They'd know what it is at the very least. That's what the global variable is. Now, each one of these items you'll see here, I have an end main. As we get further in programming, you'll have more of these little boxes, more of these variables, more of these loops and various other things. Now, if I declare something globally, every one of these boxes that I create can see it. If I declare something locally, only this box between these braces can see it. That's kind of the example I would give. If you have a whole bunch of boxes sitting side by side and you put stuff in them, whatever's inside can't see to the box to its side, but it can look in the air above it and see what's up there. That's a global variable compared to a local. So there's a couple of analogies to hopefully give you the idea. Now, that is essentially how your loops work. This is just, like I said, a basic introduction. We'll do a little bit more later. For example, later we'll take a crack at that psychic guessing game. We'll add a loop or two to it, and we'll see how it runs with that little addition. And we'll see how to add a loop to something like that. And of course, we'll do a lot more. I will tell you this. If you've ever watched Back to the Future, Marty McFly's biggest weakness, according to Doc Brown, is he does not think fourth dimensionally. Now, if I were to run this loop, you see a single line of code here. I is now this. But you have to think fourth dimensionally when you look at this. How many times is this loop going to run? If I look up here, well, just looking at the various things, it starts at 0, it goes to 5, it's going to go up 1 each time. It's going to go 5 times, 0 to 4. Now, what is going to happen in here each of those times? I write a little 0, well, it's going to print this. I write a little 1, it's going to print that. 2, 3, 4. And there may be some math going on or some other stuff. This is just the simplistic example. But you have to think what's going to happen each of those iterations. It means one rotation of the loop. What's going to happen each time. So you have to think fourth dimensionally. And that's your basic rundown on loops, hopefully, and a couple of other terms and stuff. Hopefully that makes sense. If you have any questions or anything, just let me know. And that's all.